Hello YouTube, I'm thankful for you following through this tutorial, and as I promised, I said I was going to show you something else to do with algorithms. And in this time I'm going to use the stack data structure here, and this uses an algorithm of pushing and popping elements, at the end of the list. And you must be wondering, what is an algorithm? An algorithm is a solution to a problem requiring efficiency. So in this tutorial, here's what we're going to do. We're going to create a stack class and we implement our algorithm as a stack. So here we're going to say class. We're going to be using everything with length here. So let's take it as a put it all together lesson, and then stack here. We're gonna do the value for the double value equals to an empty list, and we're gonna have the num au equals to 0 for the number of elements that are in the list. We're gonna have a size here, and it's gonna be currently at 0. And there's a better way to do this, but I'll just do with the easy way for now as we are growing. And we're gonna define our init function here, that is the constructor. And now constructor here, we're going to make sure that we also receive a size value from the user. This coming from the user, so that we say self.size, the one we had in the class definition there. We're gonna reassign it to a size, sorry about that. And then the next thing we need to do is self.ddvalue is equals to an empty list. But now you see we're repeating the same thing, because when we create our constructor here and our object is instantiated, we need to have empty list because there's nothing there. So we might need to get rid of this because it's unnecessary actually. So the next thing we do is we are going to be creating the easy functionality of stack class, that is the isEmpty and isFull. So we're going to say def is empty, and self it's automatically done for us. So this is empty. It's going to return a boolean as in true or false. It infers within the value that has been sent whether it returns true or not, and if it is true, then this is empty. So we're going to say num of elements, sorry about that, we need self.num of elements is equals to 0. That means we're at 0. That means there is nothing there, it's empty. If it is 0, that means it will return true after this inference, and then that means it's empty. Def is full. That's just the opposite of that. What we're gonna return here, we're gonna return number of elements. That's a self. Be careful about that self thing. Number of elements is equals to now what is number of elements equals to 0 again? No, we need to find the end of the list. So we're gonna say self dot size. Now the size of the stack. Now you're thinking that the size is being incremented, yes, but how are we going to get the last element? We will see that in the next function we're going to create. But here we might also want to say -1 because we are starting off at the 0 point. We are indexed at 0 at the face. So if you insert 10 elements, they're going to be 10, but we're going to be counting from 0, 1 up to 9. So in all there are 10 elements. So we need to say size -1 here, and then what we need to do now is to create the push and pop. We'll start off with the push. So what we need in the push function, we're actually inserting values. So what we need is like self.dval, and this is our list, and we need to put a value there. So we're going to use what we have used before, the apparent here. And what we need to put when we're pushing, we're actually inserting a value. This will usually come from the user, of course. So the user will say let's say value here. You give us a value. So what we're going to do, we're going to append to the list a value, and then after appending to the value, what we're going to do, we're going to increment our number of elements because we added something. So we're going to say number of elements equals, all right, I know the reason for that. So again, dot number of elements, or just say plus equals here to make it faster, +1. We incremented the value. So now here's the thing. So the pop function actually removes a value. So the thing we're gonna be doing here is primarily decrementing the number of elements that are in there when we pop a function. So we're gonna say self dot number of elements plus equals it's not plus but minus equals 1. because we actually reducing the values, we are removing an element automatically. So that's how you're gonna do it. And then when we pop a function, we might actually need to know what has been popped. So if we run this as is, it will remove, yes, the number of elements, but we will not see that implementation in our output. But we'll get back to this. Let's just show forth what we're doing, or let's implement it in fact, so that you may. So let's say cdd file, and then what you need here is cdd file. So we're going to say cdd file. When we pop the elements, we need to remove something. So what we need to remove, self. Again, this is the easiest implementation I can give you for what we have learned. Of course, there are many other ways to do it. So we're going to say -1. So what it's going to do, this -1 is going to go on to the end. This is an end. Start from the end, -1, remove that element, so that the function will decrement by -1. So that's how we're doing it here. So, and when we go down, I think we are done with the 6. Just need a print statement here, print stake. And when we print our stake, we need to do a print statement like contents of the, oh, sorry about that typo, contents of the stake. And then we print the contents of the stake. Of course, we need to print source.td5. That's will print our list, and we go down here, way down underneath from the code we had last time. Says stake equals stake. Create that instance and pass in the number of elements we'd expect the stake to be. That's how the stake is assigned to you when we say it. Sophie up here, if you remember, that's the size of the stake. So when we go down, back down there, we'll say stake dot push. We should have a function to push. I'm gonna just put a run bomb, then duplicate these with Ctrl D, and then just put another value there, and then 8 here, and then 9 here, of course. Then we print our stake. So we're gonna say stake again, then dot to call our stake, and after calling the stake, we are able to print our stake. Let's see what's happening right now from what we have so far. And as you can see, 18, 12, 8, 9. That's it. Our string has been printed, and we're getting our values. And then if we do a pop here, what happens? Stake dot pop, and then we do again stake dot print stake trace to see if one value has been removed. And as you can see, 9 has been removed. So the last element that entered into our list here is the first element to leave again. So that's why it's like a leaf or kind of thing, last in first out kind of principle. But what you want to do when dealing with this stake, that's why we put in this is empty, is we need to check as we insert our values if the list is still empty, or if the list is still holding more values, size to hold more values, or it is free. So because otherwise you're going to receive an error to that. Let's see what happens if we duplicate more values here. Let's see what happens to the console. I'm sure that's more than 10. They're getting in. And then what happens when we pop our elements? So we're just gonna have this.